The word of God in Matthew 5:6 says, "Blessed are they which hunger and thirst after righteousness, for they shall be filled." Today we're going to look at the solutions to the relations, functions, and graphs questions on the June 2017 paper 1. So I'm Teacher Alton, and I'll be leading you through the solutions, and this comes to you courtesy the Math Ministry. So question 46 gives us a number of diagrams as our choices and wants us to determine which of those represent functions. Now, there's only one correct answer. So let us see how we can actually determine what that answer is. So we're going to draw the different diagrams and we're going to go back to the definition of what a function really is. So option A gives us a diagram where you have your arrow going this way, right? Two arrows here. And of course, that's option A. Option B is a little more complicated. You have four arrows going here. 1, 2, and you got two arrows coming from here into that. That's option B. Option C, of course, the arrows are going that way. You have the diagram in front of you. Just in case, by chance, you don't, well, that's what the diagram looks like. Option C right, you got two arrows coming here and one arrow coming this way. And finally, option D right. And of course, our arrows are all going in this direction. Now, let's start off with what these two circles represent. Your domain and your range. So the domain and the range will be determined by the direction of your arrows. Usually we'll write the domain first, followed by your range. Now let's look at what the important issue is here. What is a function? Now I'm going to use the same arrangement as stated in your various choices, where your domain is denoted by the second circle and your range by the first. Now, what constitutes a function really is that you must only have each of your object in your domain being mapped on to one and only one element in your range. Let me repeat that. So each, I'm going to write it here if you want, each member in your domain must map onto only one member in your range. Now read that a couple of times, make sure you understand what it is saying, and then we'll examine the diagrams above. Each member in D must map onto only one member in your range. Right, let's examine each diagram. So remember, your domain are those members on the right. So yes, this is correct. This member is only mapped onto one. But look at this member here. It's mapped onto 1, 2. So this is not a function. This satisfies the first part, second part, but look at the last one here. It's mapped onto 2, 1, 2. So therefore, this is not a function. Similarly here, this member here is mapped onto 2. No, not supposed to happen. It must only map onto 1. So this is not a function. But this one clearly satisfies the definition where each member in your domain, these are your members here, is only mapped onto 1 and only one member in your what? In your range. So your answer will be answer D. Now, just to tease you a bit here, watch this. And I'm drawing it now how it's normally drawn. I'm going to put your domain first, followed by a range. Do you think this constitutes a function? Let's go back to the definition. A function exists where each member in your domain is mapped onto only one member in your range. So let's see if that is satisfied here. First member is mapped onto only one member here. Second member is mapped onto only one member here. Third member is mapped onto only one member there. So yes, this is a function. So what's the difference between diagram D, which is here, which we said is a function, and diagram E, which is also a function? Well, it depends. We can go a step further and classify the type of function. This function here is what you call a one-to-one function, where only 1 to 1. So each of the member in the domain is mapped onto one distinct member, different member in the range. But this is not happening here. Although it is a function, this member and this member is mapped onto the same member in the range. Are you seeing that? So in this case, although it's a function, it is called a many to one function. So I just thought I will make that distinction to give you a little recap on functions as shown in this problem, and who knows, it may pop up in later multiple choice type questions. So that takes care of number 46. Let's proceed to question 47. Right, so you're given a question here involving a graph, and I'll put in the important aspect of the graph that should interest us here. You have a line being drawn, straight line being drawn. This is y, this is x. And let's put in the information that relates to what the graph is saying and what the question is asking. Is -2, and this is 3. Right. So the straight line, and the straight line here is named AB, cuts the y-axis at, and we need to find the coordinates now. This is your y-axis here. It cuts the y-axis at this point right here. So what is the coordinates of that point? Well, we know coordinates are always written in the form x and y. So you must read your x value first, which corresponds to the point with an x value of 0, and your corresponding y value is your vertical distance. To arrive at that point, it is below the axis, so it will be -2. So your answer here will be 0, -2. That is option D. Let's proceed to question number 48. Right. Let's take this off. Okay, number 48, you're given a function h of x, and they want you to find what is the value when x is 6. Right, so h of 6, you substitute, it's minus 6, h of minus 6. Where you see x, you write minus 6, and then you simplify. So this is 6 by minus 6 by 3 is minus 18 minus 2 over 5. This is minus 20 over 5 is equal to minus 4. Right, that answer will be A. Okay, let's go to question number 49. Question number 49 relates to a number line which shows the solution of an inequality. So this is your number line here, and I'm going to put in the values that interest us. Minus 2, it's an open circle, does not include that value, as well as an open circle here, and the value 3. So they want us to identify what this inequality is in terms of the solution. Well, once you do not include values on your endpoints represented by an unshaded circle, then we know that those values are not included. So we cannot put an equal sign here. We cannot put an equal sign here. That'll be incorrect. So you're not including minus 2, you're not including 3, so therefore your inequality must be written like this, saying that x is between minus 2, x is between minus 2 and 3, not including those values. So your answer here will be D. Let's go to question 50. Right, 50 has another graph, and this graph is in the form of a parabola, and this parabola touches the x-axis like that at 2. No, that's not the x-axis, sorry. Let's redo this graph, take out the x-axis there. Right, so it cuts the x-axis right here at 0 and 4. Right, so the vertex has an x-coordinate of 2. Right, that's your vertex right here. Right, let's see what they ask us. The values of x for which y equal to 4 minus x minus y equal to 4x minus x squared intersect y equal to 0 are. So let's see the values of x for which the graph intersects y equal to 0 are. Okay, let's write that. It's written in a way we want to find the values of x for which y equal to 4 minus 4x minus x squared intersects y equal to 0. Now, this is your graph, and your graph is y equal to 4x minus x squared. So we know what the graph is, but the question is, do we know what this line is on your graph? So let's find it. Y equal to 0 is your horizontal line cutting the y-axis at 0, right here. So therefore, this is your line y equal to 0. Just to prove a point and show you another example, this is the line cutting the y-axis at 4, so this will be the line y equal to 4. Now, if you had another number here, let's say that's 6, and you pull a line this way, all these lines are parallel to your x-axis. This will be the line y equal to 6. Now, if we were to change the position of the line and draw it vertical, what do you think the equation of this line will be? Which axis it cuts? The x-axis? Which number it passes through? 2. So this will be the line x equal to 2. Last one. If we were to draw a vertical line coming down here, cutting the x-axis at the number 4, it will be, the equation of that line will be x equal to 4. So coming back to the question now, we need to find the x values that this line here, y equal to 0, intersect this graph, and it occurs here at this point and at this point. So your answer will be at x equal to 0 and x equal to 4. So that is answer A. Answer A. And our final question in our discussion of relations, functions, and graph takes us back to a function here. So in question 50, we need to come up with a rule connecting our domain and our range. We're given some numbers 2, 5, 8, 11. And these numbers are mapped on in your range now to 14, 11, 8, and 5. So remember, this is your x value, those are your y values here. X is being mapped onto y, so this is the direction of our arrows. So this is your domain. Those values constitute your range of values. And of course, this is your function f. So we need to come up with a rule connecting those pairs of values. 2 maps onto 5. It seems as though we can add 3. We are adding 3 to all these numbers to x. So let's see if we can dot and cross. Dot our i's, cross our t's, come up with it. What's happening here? Your x values are being added to 3 to get your y values. Your x values are being added to 3, 2 plus 3, 5 plus 3, 8 plus 3, 11 plus 3 to give you your y values. So this will be the rule. Now usually we use f of x in place of y because the function is defined in terms of f. And of course, we usually write the f of x first. So this will be your answer. Sometimes, just for information's sake now, sometimes your function can be written like this. But this is not the case in this question. Okay, so we need to look for this one here in our choices, among the choices of answers, and what do we get? Answer D. Okay, so that will take us to the end of our session today. And remember to thirst after the righteousness of God, and you will be blessed.